This is going to be a two-part video. The second part will deal with the same topic, but I'm going to add in limiting reactants. And this video doesn't have limiting reactants. All of the two reagents, one of them will be in excess. So the first thing we're going to do is we're going to have to write a balanced chemical equation. So we have sodium phosphate. And really, you should stop the video and see if you can write out both reactants and the products. You should give that a try. Go ahead and pause the video and come back and see how you did. All right, lead nitrate. This is a double displacement reaction, so the cation and anion will switch. The sodium from this first compound is going to hook up with nitrate in this one. We just look at the charges. So we end up with NaNO3. Worry about balancing it afterwards. And then with the lead nitrate, Pb3, PO4, 2. Then we need to balance the equation. And I already balanced it, so I'm going to just go ahead and write these in. 2, 3, 6, and 1. I like to take inventory of what we have in the problem. So we have a 0.5 molar solution. I have 10 milliliters of the sodium phosphate. This one is in excess, so I really don't care about that one. And the question is, what is the mass of the precipitate? And we know that sodium ions and nitrate ions will never form a precipitate in solution, so that means I need the grams of this. The only difference between this problem and the ones that we've done before is instead of starting with grams, we're starting with molarity and volume. So from these two, I can get to moles. So 0.5 moles of sodium phosphate in 1 liter contain, now the 10 milliliters, I'm going to go ahead and convert that in my head just by moving the decimal point 3 places, 0.01 liters. And that actually gives me 0.005 moles of sodium phosphate. Now that you have the sodium phosphate, now we can go from moles of sodium phosphate to moles of our precipitate, and from there then grams of our precipitate. So 0.005 moles of sodium phosphate and according to the balanced equation, I have 2 moles of sodium phosphate for every 1 mole of lead phosphate. And in order to get to grams, we need the molar mass, and so 1 mole of lead 2 phosphate is 811 grams. Then you use your handy dandy calculator and paying attention to significant figures, which I need 2.0 grams of our precipitate. Most of your homework problems are going to look like this. The last two at the end of the video, we actually are going to figure out the volume needed to create a precipitate, but those are at the end. Go ahead and try this problem. At a minimum, try setting up the equation. Pause it. If you think you can run through the whole problem, give it a go. You can always come back and replay. So here we have calculate the mass of solid sodium chloride that has to be added to the solution. Okay, so we have silver nitrate and sodium chloride. So NaCl plus silver nitrate, and that gives us sodium nitrate and silver chloride. And the problem told us we have 1.5 liters of a 0.1 molar solution, and the question is, how many grams of this do I need to make all of this react to make this precipitate? Well, if you guess the first thing we need is the number of moles here, you're right. So we have 0.1 moles of silver, we'll pretend I didn't do that, silver nitrate, in 1 liter. And I'm going to multiply that by 1.5 liters, which then gives us 0.15 moles of silver nitrate. If I have moles of this, I can now get directly to grams by going through mole to mole ratio. So 0.15 moles of silver nitrate and for every 1 mole of silver nitrate, I need 1 mole of sodium chloride. And for every 1 mole of sodium chloride, it's 58 grams. Yes, I'm ignoring the tenths place just to make things move a little more smoothly. And paying attention to sig figs, we have 8.7 grams of sodium chloride. Go ahead and give it a try. See how you do with it, and feel free to pause and replay anytime you think you need help. So for this next one, again, we need a balanced equation, and we have how many grams of silver chromate will be precipitated when I mix these two chemicals together. So we need a balanced chemical equation. So that gives me Ag2CrO4 plus potassium nitrate. And now we need to balance it. So that's 2 potassiums, 2 nitrates, 2 silvers, 2 silvers. We're balanced. The problem told us I have 0.5 moles per liter of this. I have 150 milliliters. And the question is, if all of this is in excess, I don't have to worry about it. So then the question is, how many grams of this is going to be produced? I'm going to do this one in one great big long line this time. I'm not going to stop and break off the moles. I'm going to do it in one big stoichiometry problem. So I've been given 0.5 moles of silver nitrate. Now you can break it into 2 like I did on the previous problems if you would rather. Drawing a straight line is always interesting. In 1 liter. I'm going to go ahead and convert this to 0.15 liters. I know that there's 2 moles of silver nitrate for every 1 mole of silver chromate. And I know that 1 mole of silver chromate, and I wrote it down, is 330 grams. And so when you do the math on this one, following sig figs, you should end up with 248 grams, don't forget to put the chemical name, of Ag2CrO4 is produced. This one was the question that I said we'll come at it from a little bit of a different angle. So the first thing I need you to do is try to write a balanced chemical equation. So in this case, we have barium nitrate plus, let's see, what else do we have? Barium, no, that's silly. Aluminum. I started to write barium by the way it's written, which is Al2SO4 3. We're going to assume that that's soluble for now. Yeah, that would be soluble. No need to assume. Okay, then that's going to give us barium sulfate, which is insoluble, plus aluminum nitrate. Now I need to balance this, so I know that, let's see, we need 3 sulfates, so that's 3. 3 bariums is 3. 6 nitrates, so I need 2, and 2 aluminums, we're good to go. So the problem says, how many milliliters of this to precipitate all of the barium into barium sulfate when I've been given 0.350 moles of 25 milliliters. Now I'm going to go ahead and break this into a couple of pieces this time. So first let's get the moles of this. So for the moles of aluminum sulfate, it's 0.350 moles of aluminum sulfate for every liter times 0.025 liters. I went ahead and converted that to liters. And that gives us I think I wrote it down, yep, 0.263 moles of aluminum sulfate. Now I need to convert the moles of aluminum sulfate to moles of barium. 0.0236 moles of aluminum sulfate and according to the balanced chemical equation, for every 1 mole of aluminum sulfate we have 3 moles of barium nitrate, which ends up with my making a mistake. When I did the calculations, that number actually goes here, 0.00875, and the number I had here goes here, can't read my own notes, 263 moles of barium nitrate. I went too far in the video to go back and stop and restart. I'm not doing that. Okay, then I have to go back at the problem and take a look at what I had. I was given a 2 molar solution and I know my moles, and so I need the volume. So I'm going to take this number, 0.0263 moles, and I'm going to multiply that times the molarity, but I got to flip that upside down, so I have 0.2 moles in 1 liter. That gets the moles to drop out and I'm left with the volume. But that would be in liters. So let's take it one step further and say, what if I have 1 liter contains 1,000 milliliters? And then I'm going to write it up here because there's virtually no more room. And when you do that, you end up with 132 milliliters. That one's probably the hardest one you're going to see on your worksheet. Now the next one I'm going to do is identical to this one, but I'm going to do it all in one step. So again, it's a very similar problem. I'm after the volume. I've been given the molarity of silver nitrate. So I'm going to start with silver nitrate. And I'm going to mix it with calcium bromide. And I'm going to convert that to products. So we have 2AgBr plus calcium nitrate. Kind of cheated, I knew that 2 was going to be there, so I'll put a 2 there. Okay, so we're going to start off with what's given of the calcium bromide. So for the calcium bromide, we have 0.128 moles of calcium bromide. And I'm going to draw a big line. And the molarities per 1 liter. And I've been given the volume. I'm going to go ahead and convert that from milliliters to liters, 0.025 liters. Now I'm going to take this moles of calcium bromide according to the balanced equation. There's 1 mole of calcium bromide for every 2 moles of silver nitrate. So that got rid of the moles of calcium bromide. And I can use this molarity, 0.415 moles of silver nitrate in 1 liter. And let's go ahead and just go straight out to milliliters. We'll pretend it said what volume in milliliters we need. And if I do that, then 1 liter has 10 to the 3rd milliliters. Plugging all that into your calculator, you end up with 15.4 milliliters. And those are the types of problems you'll see on the worksheet. This is a basic one, and then on the next video I'll show you how to do molarity and stoichiometry, but we're going to throw limiting reagents in on top of it. And that's all I have for this video. Otherwise, if you need me, I'll be around tomorrow during class.